See, it is used as a rectifier. AC is used to convert AC to rectifier is used to convert AC to DC. It is used mostly in adapters, laptop chargers, and mobile chargers, and also in the CFL lamp. Also, we use this. And what is the purpose of diode? To block current to leave the battery. So we connect the diode at the end of the terminals so that the current should not flow. That also in the reverse bias, so that current will not flow. Now rectifier, there are three types of rectifier actually: half wave, full wave, and bridge rectifier. Then what is a, so in our syllabus only we have half wave and full wave. We don't have bridge rectifier. So voltage here is how much? 230 voltage to. So first of all, what is the process actually? The voltage has to we have to bring down the voltage from 230 voltage AC to 20 voltage or 30 voltage AC. Then we connect it to the diode and then output is given. So here in half wave rectifier, what is happening? There is a power supply, there is a step down transformer, there is a diode, and this is a load resistor. So what will happen? In step down transformer, number of turns on primary is greater than number of turns on secondary, and here voltage on primary is greater than voltage on secondary here. So now, so what will happen? So when you apply the AC voltage here, when you apply the AC voltage, what will happen? Only this is the output of the diode, and this is a negative cycle is not taken in. Okay, so output upon input into 100%. In full wave rectifier, there's a transformer, and these are the two diodes, and what will happen? Here it is connected to a resistor here, X and Y. RL is said to be the load resistor. So this is the input of D1, this is the input of D2, output of D1, and this is the output of D2. Together when we write here, this is the output of D1 and D2. So when you draw this circuit diagram and the waveform, all this should be in the same line. Okay. So what exactly is happening? To D1, this is the input of D1 is like this, and input of D2 is not the same way. The phase of this signal is, the phase of the pulse or the signal is changed by 180 degrees, and it's given to D2. If you don't do like that, what will happen? In both, it will be output will be same in the same way. So this is not our purpose. So only, and one more thing, only why sir, why, what about the negative? What happens to the negative? So diode only will function for the positive half cycle, not for the negative half cycle. It works only for the positive half cycle. It won't work for the negative half cycle. So these are the positive half cycles. And now for the D1, this is for the D2. Then take it together, it is D1 and D2. So this is how it works. Now, so here after that we have here, see, AC output is like this and DC output is like this. But this type of signal cannot be given to, see, this type of signal cannot be given to the power sub, to the electronic devices. It will get spoiled. So for that reason, we are using a rectifier, and there is a capacitor, there is a load resistor. So what will happen here? There is a capacitor and there is a load resistor. RL is a load resistor. This is the capacitor is C. So output of full wave rectifier is in this way, and output with capacitor input filter. So what will happen here? So this is the dotted line is the output, and then what will happen so what is happening when the signal is going down? Actually, the capacitor will charge. When the pulse is going down, it will discharge. Again, it will charge. Again when the pulse is going down, it will not go with that. It will discharge, charge, then discharge, charge, discharge. So that is how we get a straight line. So that is about the filtering process. So now we will go to special purpose of PN junction diode. There are different types of diodes again. So now what is there in? There are many diodes. So don't restrict yourself like only maybe in our syllabus only there are 3. So only there are 3 types. There are many types of diodes. Okay, which is beyond your textbook. Okay, so we have a special purpose diode. Special purpose PN junction diode. Okay, so we have special purpose PN junction diode. So what is that here? See, the first one is Zener diode. The first one is Zener diode. Okay, it is named after the scientist. Okay, C. Zener. Now the second one is what? Second one is we have optoelectronic junction devices. Okay, we have optoelectronic junction devices. So that I will explain later. First, let me explain the Zener diode. In Zener diode, if you look at the symbol, the Zener diode is in this way. Okay, it has a such symbol. This is a symbol of a PN junction diode. This is the symbol of a PN junction diode, and this is the symbol of a Zener diode. Just wait up now, and I'll start. So now this is a Zener diode. Okay, junction diode, and this is Zener diode. Now what is happening here? What is the difference between the junction diode and a Zener diode? The difference is about the doping process. What is doping? Addition of impurity to a pure semiconductor. Only comes the difference between a PN junction diode and a Zener diode is the doping process. A heavily doped, we say this diode is a heavily doped junction diode. Okay, it is also said to be a heavily doped junction diode. Heavily doped junction diode. And you know one more thing, here heavily doped both P and N. So depletion region is very thin. If you look at the depletion region, the depletion region is all less than 10 to the power of minus 6 meter. There it was around that is equal, greater than or equal to 10 power 6, but this is less than 10 to the power of minus 6, and the electric field of the junction is extremely high. So what is electric field now? The electric field is extremely high. Electric field is how much? It is equal to 5 into 10 to the power of 6 volt per meter. This much is the electric field even for reverse bias. Okay, now so what is actual purpose of this diode? See, generally this is used as a voltage regulator. This is used as a, see once again, Zener diode. What is the difference between junction diode and Zener diode? It is only the difference is about the doping. It is a heavily doped junction diode, heavily doped for both P as well as N type semiconductor. And depletion region is less than 10 power minus 6, and the electric field is coming around 5 into 10 to the power of 6 volt per meter. Now what happens in this case? If you study about the VA characteristics of this diode, of Zener diode, it is how much it is. If you draw the voltage characteristics, voltage is V, and here current is in milliamperes. We are not going to study about the forward bias. Okay, forward bias may be there the same way, but if you look at the reverse bias, it is having a sharp cutoff. This is said to be VZ. This is reverse bias, and this is forward bias. This is forward bias, and this is reverse bias. Okay, so forward bias and reverse bias. Now this breakdown, this is said to be reverse bias, and this VZ is said to be what? Zener breakdown. VZ is known as one second. So VZ is said to be Zener breakdown. Zener breakdown, that we will study. Means it is having a sharp cutoff. That is the reason why these Zener diodes are used as a voltage regulator in stabilizers. You know, earlier there used to be a stabilizer for if you go to India now also you will find stabilizers for the old refrigerator and TVs and all. You will have a stabilizer. Stabilizer means actually the current required is for AC components. You require only 230 voltage, 230 to 240 voltage. So in India, what is happening is there is a fluctuation in the voltage. Maybe it is not exactly 230. Sometimes it goes 180. Sometimes it goes 250. It's changing. It's like increasing and decreasing. So the problem is with the input voltage. So because of that, the devices get spoiled. Your electronic devices as well as electrical devices, they get spoiled. So for that reason, we use regulators. Okay, we use regulators. Zener diode as a voltage regulator. So Zener diode as a voltage regulator. So what is happening here? in this case, just 2 minutes, Adnan and
Yes.
just 2 minutes. I'm about to finish now. So here there is, you know, if you look at this one, this is actually a potential divider circuit. In potential divider circuit, we connect in one branch. When I speak about potential divider, it is like this. See, potential divider will be like this. Suppose you have two resistors, like this is the way. See, this is your input voltage, whatever it is. This is the input voltage. Now here this is resistor is R1, resistor is R2. The voltage developed across this is V1 and the voltage developed across this is V2 now. Voltage developed across this is V2 now. Now what is happening here is, if I, like, my voltage is 5 volts, I want 5 volts. I want 2 voltage here and 3 voltage. It depends upon what is the resistor you are connecting here. Suppose if you are using a variable resistor, you can increase and decrease the voltage here. So this is said to be a potential divider. This is said to be potential divider. To understand this circuit, first of all, you should know what is a potential divider. Understood, Mr. Ibad? Ibad, Sayam, did you understand this? So now what is happening here is, we are like in one of the branch, we connect, like this is the potential divider. What we do is we connect a Zener diode, and across this a voltage is developed. There is a load resistor, and this is said to be a regulated voltage. Means what? Means even though your voltage is increasing or decreasing, your output voltage remains constant. That will not change. Like suppose my mobile phone needs exactly 5 volts or exactly 2.1 volt, but what is happening is my input is changing. My input never remains same. Like sometimes it is 230, sometimes it is 240, sometimes it is 225, 235. It is keeping on changing. So based on my input, output also will change. So in that case, my phone or my laptop will get damaged. So for that reason, we have a regulator, voltage regulator. So here what is that? RS, this is voltage regulator. So what will happen? This is unregulated voltage. This is unregulated voltage. Unregulated voltage is VL. Unregulated voltage is VL. So whatever is coming out is VL. So what we do here is, we use a potential divider. So I will fix it, because the Zener diode is having in the reverse bias. This diode is connected in the reverse bias, not in the forward bias. In the reverse bias, at a particular voltage, the current remains from there onwards. If you increase or decrease the voltage, it remains constant. It won't increase. The current remains constant. Okay, sorry. For any current, voltage remains constant. For any current, voltage remains constant. Same concept is used here. The diode is used in a reverse bias. After using so what will happen? Whether your input is increasing or decreasing, that doesn't mean anything to the diode now. The diode will only give constant output. It will give constant, that is regulated voltage. Understood? So that is how it works. Is it clear? This is said to be load resistor. RL is said to be load resistor. RL is said to be load resistor. So that is how it works. Is it clear? So that is why now it is coming inbuilt. Maybe in the TVs or the refrigerators, whatever the electrical or electronic appliances you get, or it is coming inbuilt. It is coming inbuilt now. Okay. So no need to purchase a regulator. Earlier we used to purchase regulator with every electrical or electronic devices, so that to protect it from the damage. But now it is not a problem. It's coming inbuilt. Okay. So this completes your Zener diode as a voltage regulator. Now any doubts?